Download this code from codegive.com, link in the description below. OK, let's dive into adding custom headers to HTTP requests, covering various methods and languages with detailed explanations and code examples. Understanding HTTP headers. HTTP headers are key value pairs that are sent along with HTTP requests and responses. They provide additional information about the request or response, such as the content type, encoding, authentication details, and more. Why add custom headers? Custom headers allow you to extend the functionality of HTTP beyond the standard set of headers. Common use cases include *authentication / authorization * carrying API keys, tokens, or other authentication data. *API versioning * specifying the version of the API the client is requesting. *tracking / correlation IDs * propagating unique identifiers for tracing requests across multiple services. *custom metadata * passing application-specific information to the server. *feature flagging /A/B testing * indicating which experiment group a user belongs to. Content negotiation * providing hints to the server about desired content format or features. General principles. The basic process for adding a custom header is usually the same across different programming languages and libraries. 1. Create an HTTP request object *, instantiate the object that represents your HTTP request. 2. Set the header *, use a method provided by the library to set the custom header by specifying the header name and its corresponding value. 3. Send the request *, execute the request, which includes the header you've added. Code examples, with explanations. Let's illustrate with examples in common languages. 1. Python, using requests library. Explanation *. Import requests, imports the popular requests library for making HTTP requests. Custom _headers, a dictionary defining the custom headers. The keys are the header names, and the values are the corresponding header values. The header names are case insensitive according to HTTP standards, but it's good practice to use a consistent capitalization style. *requests.get, URL, headers equals custom _headers, makes a GET request to the specified URL, including the custom _headers. You can easily adapt this to requests.post, requests.put, etc., for different HTTP methods. The headers argument is used to inject the headers. *response.status _code, the HTTP status code, example 200 for OK, 400 for bad request, 401 for unauthorized. Check this to ensure the request was successful. *response.text, the response body, usually in text format like HTML or JSON. 2. JavaScript, using Fetch API. Explanation *. Fetch, URL, options. The Fetch API is a built-in JavaScript feature for making HTTP requests. Options, an object that configures the request. Method, the HTTP method, get, post, put, delete, etc. Headers, an object containing the custom headers. Body, the request body, example for post or put requests. You'll typically use JSON.stringify, to convert a JavaScript object to a JSON string. *then, handles the asynchronous response. The first .then, checks if the response was successful, response.ok. The second .then, parses the response body as JSON, response.json, or text, response.text. *catch handles any errors that occur during the request or response processing. 3. Java, using java.net.http, standard since Java 11. Explanation java.net.http uses the built-in HTTP client introduced in Java 11. It's asynchronous and non-blocking. HTTP client creates an HTTP client instance. HTTP request.new builder starts building an HTTP request object. *URI.create URL sets the URI uniform resource identifier for the request. *header header name header value adds a custom header. You can chain multiple calls to .header to add multiple headers. *get or .post specifies the HTTP method. For post requests, you'll need to provide a request body using HTTP request.body publishers. Of_string takes a string as the body, you can also use of_file for files, etc. *build completes the building of the HTTP request object. *client.send sends the request synchronously, waits for the response. HTTP response.body handlers.of_string specifies that the response body should be handled as a string. *response.statuscode gets the HTTP status code. *response.body gets the response body as a string. 4. PHP using curl. Explanation *curl _init initializes a new curl session. *curl _setopt sets various options for the curl session. *curl opt _return transfer when set to true, curl _exec will return the response as a string instead of outputting it directly. *curl opt _header an array of HTTP header fields to set. Each element is a string in the format header name, header value. *curl opt _post set to true to indicate a post request. *curl opt _post fields the data to send in the post request body. You can use JSON_encode to convert a PHP array to a JSON string. *curl _exec executes the curl session. *curl _error no and curl _error check for errors during the curl execution. *curl _getinfo gets information about the curl transfer, such as the HTTP status code. *curl _close closes the curl session. 5. C. Using HTTP client. Explanation *. Using system.net.http imports the necessary namespace. *HTTP client creates an HTTP client instance. The using statement ensures that the client is properly disposed of when it's no longer needed. *client.default request headers provides access to the default request headers, which are sent with every request made by this HTTP client instance. *client.default request headers.add header name, header value adds a simple header. *client.default request headers.authorization equals new authentication header value. For headers that have specific structures, like authorization, you often use dedicated classes to create the header value. *client.default request headers.accept.add new media type with quality header value, adding an accept header to specify which media types the client accepts. *string content represents the request body for post/put requests. You create it with the content string. The encoding UTF-8 is common, and the media type, example application/JSON. Asterisk client.getAsync, or post async, put async sends the request asynchronously. The await keyword allows you to wait for the response without blocking the current thread. Asterisk response.is success status code, checks if the response status code indicates success, typically 200 to 299. Asterisk response.content.read as string async, reads the response body as a string. Important considerations. Asterisk reserved header names. Asterisk be careful not to use reserved HTTP header names, example content length, transfer encoding, unless you understand their proper usage and implications. The HTTP specification defines which headers are reserved and how they should be used. Overriding these can cause unexpected behavior. Asterisk security. Asterisk when sending sensitive information, like API keys or authentication tokens, in custom headers, ensure that you're using HTTPS, SSL/TLS, to encrypt the communication. Avoid storing sensitive data directly in headers if possible, and consider using secure methods like OAuth 2.0 for authentication. Asterisk header size limits. Asterisk there are typically limits on the total size of the HTTP headers, including custom headers. Exceeding these limits can lead to errors. The exact limit varies depending on the server and client configuration. Asterisk CORS, cross-origin resource sharing. When making requests from a web browser to a different domain, you may encounter CORS issues. If the server doesn't explicitly allow your domain to access its resources, the request will be blocked. To work around this, you'll need to configure the server to send the appropriate CORS headers, example access control allow origin. Some custom headers might also require pre-flight requests, options, for CORS to work correctly. Asterisk caching. Asterisk some headers influence how responses are cached by browsers or proxies. Be mindful of caching implications when adding custom headers. Asterisk server-side handling. Asterisk the server needs to be designed to understand and process the custom headers you're sending. Make sure the server-side code knows how to extract and use the information provided in the headers. Asterisk character encoding. Asterisk encode your header values to comply with HTTP standards. Typically, UTF-8 is preferred, and you might need to use URL encoding, percent encoding, for characters outside the basic ASCII range. Most HTTP client libraries will handle this for you automatically, but it's something to be aware of. By following these examples and considerations, you should be well equipped to add custom headers to your HTTP requests in various programming languages. Remember to adapt the code to your specific needs and pay attention to security best practices.